want to look at the comparative statistics related to the changes in the G, because this is the new adding parameter that we have for the new version of the Solow model. So in here, I want to emphasize that we are focusing on the variable expresses in per effective worker, because that is the defined variable that we look at when we are coming up with the steady state. So then now we have a new G that is greater than the old G. So then if we look at a K steady state, we will notice that the G is in the denominator. Again, here the K is the capital star per effective worker. So then given that the G is greater now, and it is in the denominator, so we know that the new capital star in the steady state is less than the old capital star in the steady state. In other words, the output in the steady state in terms of per effective worker becomes lower when the G is higher. If we look at this from the Solow diagram, we know that if we have the G that increases, the slope of the steady state condition will become steeper, and then we are going to have a new capital star in the steady state, which is lower. So now let's take a look at the diagram with the golden rule saving rate. Now this is a Solow model with the golden rule saving rate, because at this level of the saving rate, the consumption is maximized. Then when there is an increase in the G, we are going to have a steeper slope for the steady state condition. And then it turned out that to find out the new golden rule saving rate, we need to find a line that parallel to the new steady state condition. And then we will find this in here, that the consumption is maximized, and then it corresponds to a new capital star in the steady state. So the saving rate is the saving rate that will give us this new golden rule level of the capital star in the steady state. So then it turned out that this golden rule saving rate is exactly the same, but the golden rule level of the capital star is different. That is because we know the golden rule saving rate is the capital share. Given that we assume the same production function, so the capital share remains the same. So the golden rule saving rate remains the same, even though our model has the technological growth rate. But the golden rule capital star in the steady state per effective worker becomes lower. So then that is the comparative statistics related to the changes in the G. When the G is higher, then the capital star in the steady state per effective worker becomes less. You say, hey, wait a minute, does it make sense that when the growth rate increases, somehow the capital star per effective worker becomes less, and then the output per effective worker becomes less? Does it mean when the growth rate becomes higher, it implies a lower living standard, given that when we are looking at a living standard, we're looking at a Y? The answer is no. That is because in here we are looking at the per effective worker variable instead of per worker. However, when we are talking about the living standard, we are talking about the output per worker instead of the output per effective worker. So let's now take a look at the role of the G in determining the living standard. So we say that when we are looking at the living standard, we want to focus on the output per capita instead of output per effective workers. So then when we want to see the role of the G in growth, then we want to look at the variables output per capita. So what we want to do is that we want to focus on the capital per capita instead of the capital per effective capita, and see what should be the result when the G increases. The capital per capita is the capital per effective worker multiplied by the size of the production efficiency that augmenting the labor production. So then what we have is that now we want to focus on the new variable when we talk about the living standard, which is lowercase kt multiplied by et. So now we want to focus on the capital per effective worker multiplied by the level of the production efficiency that augmented the labor production at time t. So then the K steady state multiplied by the E is somehow somehow equals the steady state value of the k, which is s tilde a divided by n plus g plus delta, the whole thing to the power of 1 over 1 minus theta, multiplied by the 1 plus g to the power of t. Let's assume that the E naught equal 1. And then what it turned out is that given that the g is higher, so that in fact the new steady state per effective worker is less than the old capital star per effective worker, which is as what we showed in our earlier comparative statics. And then what it turned out is that the g is greater now, so then it means that the 1 plus g plum is greater than 1 plus g. And then when we have it power to the t, then this number will become much larger than the old one. Therefore, when we compare the old capital star per worker versus the new capital star per worker, then we can plug in the value for the capital stock per effective worker and then the level of the production efficiency. Even though the 1 over 1 plus g plus delta is smaller under the higher g. But then when we are looking at the steady state, we are talking about the result in the long run. So that when t goes to infinity, and then given that 1 plus g plum is greater than 1 plus g, so then we know that this value will go to infinity. In other words, even though from the perspective of per effective worker, the capital per effective worker under the higher g is smaller, thus the output per effective worker is smaller. But then as the g increases, when we are focusing on the living standard, we look at the output per worker, and then given that the capital per worker is larger under the new g, therefore the output per worker is also larger under the new g. In conclusion, we say that though the capital per effective worker in the steady state is lower when g is higher, in terms of capital per worker, which is our focus, higher g will result in higher capital stock per worker. Therefore, raising the g also raises the living standard. So that's the role of the g under the Solow model.